In this tutorial, we're gonna learn how to use visual components connectivity plugin with Yamaha robots and with the RCX Studio by Yamaha.
When following any tutorial, check the lesson in the Visual Components Academy, and if the Download Files option appears, you can download the example files.
Hi guys, and welcome to this tutorial. So first, build your simulation. You can test it with running the simulation with the enabled executor with the robot. That's your program. Check that the program works. And you have successful setup and program itself. The cycle looks fine. You can reset. And in this point, let's disable the robot executor. And it can be found from the robot properties under executor. It is because we want the control hub in the end in the RCX side that the visual components program does not control the robot itself. Next, let's open RCX Studio. In this case, we can create a new project, rename it, click OK. Here we need to add new controller, double click new controller, you can rename it. And at this point, you need to insert the emulator port number. By default, it starts with the 50,000. You can keep it that way. If you have multiple controllers, you need to have individual port value there. But let's keep it here 50,000, and we're going to need that later on, establishing the connection between the visual components and the RCX Studio. So click here next. Here you need to find the matching robot that you have in the simulation. Currently we have this YK400, and it can be found from here somewhere below. And it's the XE value type. So let's select the T variant. Looks similar. Then click add. And you can have totally like 4 robots under the same controller. Then click next and let it think a bit. The creation is complete, so click finish. Yes, we want to start offline, click OK. We have the RCX running. By default, you are not seeing the 3D view. You can enable it from the left top corner 3D view. It's opened as a separate window. In this point, you wanna enable the servos on the robot. Otherwise, the connection with the visual components is not successful. So click here, servos. Motor power on. From here, you can get all of them on. Click OK. Okay, the emulator has the motors on. Just to calibrate the robot, you can click here, origin all robots and grippers. Just click perform. The robot will run this cycle to kind of zero out all the axes. Yeah. And even if the robot stays in this funny position, that's fine. Next, we can go to the visual components. And here, let's go to the connectivity tab. And if you cannot see it, go to the file and add-ons, options, add-ons, and enable the connectivity tab. And click OK. In the connectivity tab, if you don't have the server, the connectivity tab, select the Yamaha robot, right click and add server. Here we can see in the server settings that we have the port value here. And this should match the controller port that was inserted while creating the RCX project. So here we can test the connection. It's already at 50,000. If you have trial licensing or license expiring in the SDK license, it will give you a warning. It's fine. The connection is succeed. So connection between those two softwares is fine. You will get this banner. Okay. And after this, press apply in the connection editing. Next, let's add robot parameters. So in the how to use, it will explain what the variables include. And in the parameters, we need to add, first of all, robots. But by default, it will give you 2 currently, but we need just 1. Under the axis parameters, we can add axes that the robot has. We need 4 in total. These parameters will translate the pulse value to degrees inside the simulation. So we need to get these variables from the RCX controller driver settings. Next, we need to kind of use the split screen. Inside the RCX, find under the parameters this driver window. So double click this driver. You can close the jogging window. Currently the window is a bit small. Try to stretch the windows that you can see all the axes. So under the driver values, you have all the driver values under each axis. So A1 to 4. So first we need to find lead screw or lead value. It can be found somewhere down here. Passed it already, so it's here lead. So for the first axis, it's 360,000. We can copy that, insert the lead value. It's matching to the second and the fourth axes. So let's add it here, second and the fourth leads. Then we can see that the third axis had different lead. So we can copy that, and it's 12,000. The next value is the gear ration. It's under the lead value, so it's once again 50,000 in first, second, and the first 2. So we're gonna add that here. Gear ration 50,000, axis 1 and 2. The axis 3 has 1,000. We can copy paste it with axis 3, and axis 4 has 12,000. We can add it to the axis 4. The last value is the encoder pulse value, and that can be found few rows below. We can see that all of the axes share the same value, so 20,480. We can add that to all of the axes. Here we go. That should be it. We can close the driver window from the RCX. Then we can go to visual components, add next connected variables between the server and simulation. So go to the Yamaha robot server in the connectivity tab. then select Server to Simulation and right-click Add Variables. So here we are going to create the pairing between server and between the simulation values. And at this point, you need to enable the connection. So from the server right side, we have this green or circle icon. So click that. Once again, the SDK will give you a comment about your license. While the connection is on, you are able to see variables from the server side that the SDK offers. You can see the robots with the robot 1 and also the IO. So first we want to pair the robot axis values. So from sorting the list in the left side, which includes all the components in the simulation, we can maybe get the degrees of freedom, then we are able to sort it out. And maybe with signal maps, yeah, then we get only the robot. So yeah, we are now interested in the degrees of freedom and the signals. So here we are able to get robot only. Then under behaviors, we can see the RCX controller. Under here, we can see all the joints. Under the joint, we can see all its properties. And here we are interested in about the value. So what is the current value of the joint? In the server side, select the robot. And here we want to add the degrees and pair the axis 1 to joint 1. Okay, so first, while you enable the connection, then open the Add Variables window. Search the current joint value. So from the robot component all the way to behaviors, RCX joint 1 value. Then from the server side, robot 1, and degrees and axis 1. And now we want to create connection between these two variables. So click pair selected. Then continue to the joint 2. Same thing, joint 2 value and axis 2 pair selected. And repeat this to all joints. Here we go. And next, we want to connect the IO signals. We can still keep the same component visible in the simulation side. So here we want to connect the outputs. Depending upon your program, what IOs you are using. In my case, I'm using in the outputs, for example, we are using output 10 to execute in the gripping. So select from the IOs output 10. From the server side, IO, EO, we can see the sorting in the outputs are a bit different. They are going with these groups. So 10 is going to be in DO1 and DO10. That's a matching 10. Here selected. Second set of IOs are in my simulation in the range of 101 and 2. So I select the server side DO10, and here we have DO10.1 and 10.2. There it is. That's all the signals we need from the server simulation side. And note here that the first 10 IOs in the VRC, in the RCX side, are reserved for the system. So use other signals than below the 10 first IO. Also, the Yamaha SDK is limited so that we are only able to write digital output values for the robot. So we are not able to use the digital input signals in the server side. And you can close the create variable pairs. Select then simulation server, right click and add variables. Here we want to connect the IOs. These I'm using in my simulation is DO201. Let's select from the server side 200 as well, so 21, 202, so DO20 and 2, and they're selected. So these should be all of the variables that we need to run this simulation. In this point, you can go to the Program tab, in the Visual Components, select the robot. Depending about your case, you can create the logic and the programming inside the Programming tab. Then you can use the Post process to export the programs. So click Post process, select the Yamaha download. So we are exporting outwards towards the robot programs. You can name the program. I have already one export here as main. I can rewrite the main and save it. Overwrite existing one. The Visual Components will give you this pop-up that translation is done. Okay. Then we can go to the RCX Studio. And you can bring the programs to the RCX Studio with the Restore option, top of the window. Click Restore. You want to select the file, browse, select the folder you save it to programs or exported the programs onto Visual Components. You need to select from sorting that we are searching program files. We get the visible the main program. Click Open. And after that, okay. Yes, we want to override. The import was complete. And then you can see that the main program is added from the window tree under the programs, under main program here. So this is the export from the Visual Components. Before this functions correctly, you need to add the hand variables under the coordinate system and hand. So the default tool is going to be the H, so-called hand, H0. So you need to select the robot that is using it. So robot 1. But if we are using the default tool, which has 0 offset, so you can adjust zeros to each field. With Control S, you can save. And that should be fine, like that. We can close that window. And the VC side, we can go check in the connectivity tab. The server is still running. Good. We can leave this window open to see the variable values that are running while the simulation is running. Now we want to maybe use the split screen just to see movement in the simulation robot and also control the program window of the Yamaha robot. So now start the program from the Yamaha RCX. Start. It should break the first so-called input value, and then you can start the simulation from the Visual Component side. And you can see already that it clones the position from the RCX. Here we go. Now the program is controlled, or the robot movement is controlled from the RCX. Simulation behaves simultaneously with the Visual Components. Thank you for watching.